So, welcome friends. Let us start the new topic after discussing about the bending stress and the relation between the moment and curvature. So, today we will discuss about the new topic, that is our shear stress. Shear stress. So, the shear stress arises due to the shear force in the beam, so that is known as the shear stress. So we can define it as it is the shear force in the beam. Okay, so the stress arises due to the shear force in the beam is known as the shear stress. One thing we need to remember, that uh, a designer has to see that the beam is safe not only in the bending but in shear also. Okay, so the expression for the shear stress also we can find out by considering a beam. So let's say here we have a beam. So considering this beam here, so we have considered an elemental part of that beam. So consider this segment of the beam as these are the two sections, like a section and b section. Okay, so if this distance is x from the one is, and this segment which we have considered, so the length of this elemental segment is delta x. So this part is considered delta x, and this is at a distance of x from this is. Okay, so let the bending moment at the section AA is like this, it is m we can say. And similarly the bending moment for the section BB, if we can say here, so that will be at a distance, if this is for this is m, then here we will say it is m plus del m. Okay, so that is the bending moment at section BB. At this section the bending moment is like this. Let see, this is a beam, a fiber we will consider here. So this is a fiber, let's say it's a CD. So the CD beam is an elemental fiber. If the neutral axis of this beam we will consider here, it is the neutral axis, and this CD is at a distance y. Okay, so we can say, so this distance here, I'm just trying to display the distance, it's at y distance. Okay, at y distance from the neutral axis. Okay, and the this is also del y, this part. Okay, the width of this CD we may consider as del y. The thickness also we can say, okay, it is the thickness of the this beam CD. So let me draw this here. If this is the neutral axis, so now we are considering about this small part, small segment CD. So let me draw it like this, we can say. So if here is our CD, okay, so this is the CD, and this particular distance is we can say it's a small, this is this part is del y, and here I'll write it, yeah, so it's del y, this part. Okay, so this is del y, and this is at a distance y from this neutral axis. If this is equals to b, this is B, and we can say from this neutral axis, so this particular distance is, it is YT, we can say. Okay, if this is our figure A, this is B. Okay, so the force will be applied on both the sides. Okay, if let's say here it is the CD, and we can say this is, if this is CD, this fiber I am just trying to draw here. So a force will be applied on this direction and in this direction. So what will be that force that we are just trying to find out? If here we can represent it, the intensity of this shearing stress, it is Q, we can represent. So we can find out the bending stress on the left side. Here what will be the bending stress and what will be the stress on the right side also. So for that, earlier we have derived an equation for the bending stress. So we know that M upon I is equals F upon Y. So by using this formula we can find out the bending stress here. Okay, so on the left side, so bending stress on the left side is what? This is our bending stress. So F can be written as M upon I, this Y. Okay, so let me write it properly. So the bending stress on left side of elemental fiber can be written as M upon I Y. Okay, so this is bending stress. If we want to find out the force on the left side, so the force on the left side of element, so that can be this multiplied by the area. Okay, so that is what, that is B into del Y. So we can say it is equals to M upon I Y B del Y. Okay, so this is the force which is applied on the left side of the this fiber CD. So here we can write the force, that is what, M upon I Y B del Y. Okay, so similarly on the right section we can also find out the force. So let me erase this. So similarly, force on the right side of the element, so that is equals to what, it is M upon M plus del M upon I into Y del Y, Y B del Y, del Y. So this is the area and this is our moment. So we can say like this, this is the force on the right side of the element. So the unbalanced horizontal force on right side of elemental fiber, so that can be written as, it's M plus del M over I y b del y minus the force on the left side. Okay, so that is what is the value of the unbalanced horizontal force that we can find out. So by putting the value of force on the left side, that was our m upon I y b del y. Okay, so this term will be cancelled out if we will solve this equation. So finally we will get it's del m upon I y b del y. Okay, so there are a number of such elemental fibers about the CD. One fiber we have considered, but there are a number of elemental fibers. So hence the unbalanced horizontal forces on the section, we can say, uh, let me write it here. There are number of such elemental fiber above CD. Okay, so hence unbalanced horizontal force on section CD, that can be written as its integration from y to yt, and it's del m by I y b del y. Okay, either we can say like this term can be written as it's del m upon I, and this integration part from y to yt, and y b dy. Okay, so this we can write, and let me let the intensity. So we have earlier discussed in the previous section that on the fiber CD, this was CD, so the intensity of the shearing stress on this element CD we have considered as Q. Okay, so then the then equating the resisting shearing force to the unbalanced horizontal force. So what exactly this force due to this intensity, so can we can put the values. So what exactly the value will be? It is QB. So the width of that fiber is del x, we have considered this del x, and B into this intensity Q. Okay, so that can be equals to this step. Okay, so we can write directly here as it is QB del x, that can be written as this m. So I'm just trying to erase this data which is not used for me now. So this is the, so this is our expression. So what will be the value of this Q? So let me write it here. So Q can be written as it is del m upon del x 1 by bi. Okay, this we can put as this I, and this b and del x will be just on the denominator of the right side, and this into this y2 yt, and yb dy. So as del x tends to 0, so in that case uh, q can be written as its dm over dx 1 upon bi, this integrational part. So in place of that we can write as it is a y bar. Okay, so where this is equals to the moment of area moment of area above the section under consideration about neutral axis. Okay, so but we know that dm by dx can be f, so finally we can write as q is equals this is f upon bi a y bar. Okay, so the above expression gives the shear stress at any fiber y distance above the neutral axis. So at a distance y above the neutral axis we can have this expression gives us the shear stress. Okay, so thank for watching the video. For any suggestions you may write on my uh, youtube my channel. Okay, so thanks for watching the video.